Bismillahirrahmanirrahim. I hope you're fine and doing well. Today we want to discuss on BGP summarization or BGP aggregation, and this is also a very important document in BGP. So what's the benefit of BGP summarization or aggregation? As I listed before in this text document, BGP summarization reduces the size of routing table. That's very good. It reduces the size of routing table and also is best for um, too small the size of routing table, and in this case the router's overhead will be reduced. And BGP summarization also minimize the number of routing updates, and this is more complex than IGP protocol or interrogated protocol. In order to summarize, at least one subnet must be in the BGP table. Okay, so we want to work on this subnet, and we want to work in the subnet, and we want to summarize the subnet. By default, this subnet is advertised in one of our nodes, and this is not summarized right now, and I want to summarize this subnets in our practical environment. So as you see, this is our subnet ID, and this is our subnet mask. These three portion is belonging to network, and the last portion is belonging to host. Okay, if you want to summarize, you can summarize very simple. I think you have information um, that how can I summarize a subnet. If you do not have any information, let me know, and I will help you that how can you summarize a subnet to reduce the size of routing table. In this case, when we summarize this subnets from these four subnets, just we have this single subnet, okay, with this subnet mask. So I don't want to discuss right now on summarization that how can I summarize the subnets, because this is not our focus and not our lecture. So just our lecture is on BGP summarization. How can we implement summarization on BGP? So as you see in this diagram, we have three different AS path. This is, for example, AS 100. Assume that is 100, is 200, and also this is AS 300. So we advertised four subnets, four different subnets, N or 3, and is 300. Then this four subnets updates coming to R2, and from R2 these subnets are advertised to R1 as well. In this case, if we have more subnets like this, then the size of routing table in R2, R1, and R3 will be big, and at that time the router will face with overhead. And when we want to reduce overhead on our nodes and CPU utilization, memory usage in our live network, that's very important, and that we will implement BGP summarization or aggregation in this case. So first of all, we have to implement or configure following tasks. First of all, I will configure BGP between R1, R2, R3 as per diagram, and also advertise all directly connected interfaces through BGP. Okay, advertise the loopback interfaces of router 3 on BGP as well. Then we will configure summarization on this subnets in R3. So coming to command line interface, IPs or assigned before, just I wanna check. Okay, just connect directly with R1 or 2. Connect with R1 or 3, and this is the loopback. Or 2, and these are the loopback interface. And also I want to summarize these subnets. So in this case, just first of all, I want to configure BGP peership between these peers. So just I want to ping my neighbor. Advertise loopback interface as well. No to summary, no synchronization. Okay, done. First of all, I want to ping. Okay. And coming to router 3, private router 2, I do not have any neighbor, just advertise the subnets. Trying to find IP. Okay. Configuration has been done in all 3 nodes. Okay, just I want to check the BGP database table. Show IP BGP summary. Just first of all, I will check the neighbor table, and coming here, I will check neighbor table. I have 2 neighbors here. Just I have 5. I received 5 prefixes from R3 and 2 prefixes from R1. Okay, right now you can see all the prefixes that we advertised before in R3 that are coming here from this next hop and this AS path. So in this case, if we advertise more subnets, assume that we advertise around 100 subnets or 200 subnets. In this case, our routing table will be very big, and at that time, it will has effects on performance of our router or nodes. In this case, we should summarize the subnets that's locally originated at that node. So network or subnet 3 is locally generated in R3. So we should summarize this subnets in R3. Okay, so coming here, Very simple. Just enter to your BGP. In this case, just type aggregate address. After that, add your summarized subnets after calculation. Just I'm coming here. This is my summarized subnets. Okay, you can copy this and paste it here with the subnet mask. So maybe 3100 and add aggregate mask as well. 255, 255, 248 and 0. Just add this command for summarizing this subnets. We summarized this subnets before, and if you want to have full information that how can I summarize the subnets, you should um, get this information from my other video that I allocated for this lecture. So I don't want to discuss right now on this that how can I summarize the subnets. Just I want to implement and I want to configure summarization in BGP with this command. Okay, enter. Then I will check the BGP table. Right now you have one extra subnet here, that's summarized subnets, as same as your previous subnets as well, as you can check here. Okay, the summarized subnet exists here, but also our previous subnets are also exist in this routing table. That's not effective because we discuss on this that we wanna summarize these subnets, and instead of these four subnets, just I want that one subnet exists in this table. In this case, I add and I configure summarization in R3, but unfortunately these individual subnets also exist. So in this case, come to my node path. Note, aggregation or aggregate address command advertise the aggregate route along with individual prefixes. Which prefixes? These prefixes. Okay? These prefixes. As I discussed before on that. So coming to Notepad. For solution of this issue, we can use summary only command at the end of our aggregation command. So for avoiding and for solution of this issue, that just we want to have and receive one summarized subnets instead of these individual subnets, just coming to R3 and add one basic command. Okay, router BGP 300 aggregate 30.1.0.255.255.248.0. Okay, after that add question mark. In this case, I don't want to use advertised map, a set, attribute map, just I want summary only. Okay, just summary. That's correct? Okay. This command is very important. So after that, I will check again. Okay, just right now I have a summarized subnet here, and I do not have individual subnets that I have before. Right now you can ping for all these subnets. And instead of these subnets, just you have this single subnet. as you see that the routing table size is reduced from the previous. This is the previous one, and this is the after summarization. This database table is very small, so you can ping 3.1.1.1 30.1.2.1 and 30.4. You can pick. This is the feature of summarization. And one thing you should be mentioned that when I check show IP BGP, my summarized IP here /21. In this case, I see one uh, comments here, that's atomic aggregate. What's atomic aggregate? Atomic aggregate attribute is informational attribute. This is an informational attribute and tells to BGP speakers that this prefix is a result of route aggregation. This is an informational attribute that tells other BGP speakers or neighbors that this prefixes the aggregated and summarized prefix. And some information like a path or other attributes from um, the origin may be missing. So in this case, that's very important to know what's the meaning of atomic aggregate. This is an informational attribute that tells other BGP neighbors and peers that this attribute is aggregated by this AS path. Okay. So I can check here as well. Show BGP 30.1.0.0/. Okay. This comment is also exists here. As you see, aggregated by is path 300. So this is an information attribute. Okay. So also you can check show IP BGP 30. Okay, we have this attribute as well. This is the BGP database table. Also, you can check the routing table as well. So this is the first lecture of aggregation and summarization in BGP that I discussed with you and I worked. So in this topology, we configured the route summarization that or3 will advertise the summarized route information to or2 and or2 to or1 as well. So this is the end of lecture. If you have any comments, let me know. Thank you for your watch.